So what we're going to be doing in your books today, follow along with me. The directions are going to feel a little bit weird, but just follow along. So we're going to start off by drawing a rectangle.
What about square?
I mean, it's a special kind of rectangle, so if that's what floats your boat, don't make it too small. Just don't make it too small. Here's the parameters for this though. There's colored pencils on the desks because the colors show up a whole lot better. Or there's markers. You're going to start on a dot and end on a dot because we're going to count the spaces between the dots. All right? Draw a rectangle. Start on a dot, end on a dot. Don't make it too small. You can make it as big as you want, just don't make it too small.
We can make it anywhere, right?
You can make it anywhere on the page. Start on a dot, end on a dot. All right. You guys okay with those directions so far? Cool, you're already doing better than my class earlier today. Yes. Yep. Nope. Totally fine. Totally fine. You can do yours whatever size you want.
I can put whatever size.
Whatever size you want, as long as it's not too small. Just don't make it too small or it's hard to work with. Nope. Just draw a rectangle. Technically, a square is a special kind of rectangle, so if you want to, just don't make it too small. Now, I want to count how big the sides of your rectangle are. We're not counting the dots, we're counting the spaces between the dots. So like right here, that's 1 space, 2 spaces, 3, 4, 5. Mine is 6 squares tall. If I count the space between the dots, I get how tall the whole thing is. I want to do that across the top as well. You're not counting the dots, you're counting the space between the dots. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13. Mine is 14. All right. Does everybody have their rectangle on there? Yes, no, maybe so? Again, a square is a special kind of rectangle, so if you have a square, you have a rectangle. Count your sides.
The square was the original shape.
You thought the square was the original shape?
Yeah.
I don't quite know what you mean by original shape, but
Because you said,
sure.
you said a square is a special type of rectangle.
Yes. A square is a special type of rectangle.
That means that the rectangle is the original shape.
Okay, it's kind of like when I say a square is a special kind of rectangle, that's like saying a golden retriever is a special kind of dog. It's one specific kind of dog. Squares and rectangles have the same relationship. All right, have you guys counted how big your rectangles are on the sides?
Yes, ma'am.
I want to calculate the area. How do you find the area of a shape like this? Yep, length times the width. Yep, so I want you to write this off to the side. This is another reason why I gave you guys markers, because it shows up a lot better than your pencil. So for mine, what would I multiply together? 6 and 14. 6 times 14. I need to grab my calculator for that. That's 72. Don't worry about that. So the area here 72 and 12. I think this is 84. I've got to grab my calculator to double check. Yay, I did it right. Okay. You guys good so far? Somewhere inside your rectangle, I want you to draw a line that will cut your rectangle into parts.
How many?
There should be 2 parts. It doesn't have to be in half, though. Like, I'm going to draw mine right here. Okay?
What if it cut? Okay.
It's okay to cut it in half. I wouldn't recommend that just because it's going to make it harder to see some of the relationships, but it's fine. Pick somewhere on your rectangle, draw a line to cut it into 2 sections. They do not have to be the same size.
Well, mine's this way.
So what I want to do now is I want to figure out from the edge to where I drew that line, how far is that? Count the spaces, not the squares. 1, 2, 3, minus 4. And I want to do that on both sides of the line that I cut it on. Okay? I want to know how big each side of it is. Count the spaces, not the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So we start from the top.
Yep, you got your rectangle on there, right?
Yes.
Okay, do you know how big the sides of your rectangle are?
How big the sides are?
Like what I have here in this red color? Do you know how big your sides are? You're counting the squares. You're counting the spaces between the dots.
Huh?
Count the spaces between the dots.
How did you get here?
Yep.
1, 2, 3, 4.
It's not even hard.
Okay, but I wasn't talking to you. Oh, you're counting the
You
dots?
need to get off that damn phone.
Okay. So you're counting the spaces between the dots. Because I want to know how many blocks high it is. So here's 1 block, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes.
Yeah, I got it.
Yep. So now you're going to cut your shape.
In half?
It doesn't have to be in half. You're just going to pick a spot and cut. Yep.
Okay. It's cut.
Yep. Okay, so now figure out how far this is.
It's 4.
1, 2, so write 4 up there.
Okay.
And then figure out how big this side is.
2, 3, 4, 5, 6, 7.
7, perfect. It does not matter where you cut it. You can cut it wherever you want as long as you take your rectangle and cut it into 2 parts. Got to keep your mask on for me, dear.
So from here, did you count this one?
You do not count the dots. You're counting the spaces between the dots.
I told you. It doesn't
Oh, sorry.
work. It's broken.
Got it.
She's
Okay, so like
raggedy.
1, 2, 3, 4, 5, 6, 7, 8. This one's actually 9 over here. It's 9 squares tall. 1, 2, space between the dots. So like here's 1,
So mine
2,
is actually 5.
3,
So it's just one of
4,
those.
5, 6, 7, 8, 9. And then you do the same thing across here.
Mine is actually 5.
So what would this be?
Probably
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes. So put a 15 here, and then this would be how much?
Probably 4.
4. Yes. Does anybody else need help with their rectangle? Okay.
I counted the spaces.
Counted the spaces
And then I did the
between?
link times with 136. I just
Wonderful.
need to know where you get the line and stuff from.
You just pick a spot to draw a line,
Oh, okay, that's my
and then you're
spot.
counting how big this is
And then
and how big that is.
Which I can do by dividing it in half. Basically. I mean, not half, but like.
Yeah. Question.
So I just
1, 2, 3, 4, 5, 6. Yep. 1, 2, 3, 4, 5. And so 11. Yep. Looking good. Question. What do you guys notice about these 2 numbers?
They equal the top.
They equal the top number. No matter what you have on your page, these 2 together should equal the top one, right? Okay. I want to write down the area for this whole rectangle in two special forms. We're going to call the first one sum form. Sum form. What does sum mean to do? To add. I'm going to find the area of this space over here, and I'm going to add that to the area of this space over here. So I'm going to find the area of each piece, and then to get the area of the whole thing, I'm going to add them together. I'm not actually going to add them. I'm just going to write down what the two numbers are, and I'm going to put a plus sign between them. So how do I find the area for the little blue rectangle on mine? 6 times 4. Mm-hmm.
What if they're not equal?
That's okay, because mine aren't equal either.
Okay.
Yep.
Those two numbers are different. Like,
Mm-hmm.
it doesn't add up to my top number.
Oh, it should.
You sure?
It should. Let's see. 1, 2, 3. This one should be 4.
It's 4.
Okay. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Say 15, but it's 20.
The whole thing would be 15 across if you count the space between your dots.
Okay, so is it supposed to be 19?
Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yes, that should be a 19 up there. So you'll probably have to redo your area.
We put the sum of those two numbers.
Yeah. All right, so the area for my blue one was 24. So I'm going to write down 24 plus, and now I'm going to find the area for the other part of my rectangle. How do I find the area for the other part? Same thing, length times width. So I'm going to do length times width. I'm going to do 6 times 10. So on my rectangle up here, the area for the bigger part is 60, right? What do I get if I add 24 and 60? 84, which is the area of the whole thing together, right? We're going to write down another form here. This is called product form. Product form. For product form, I'm going to write down what I was just multiplying together. So I did 6 times this side, right? And this side is made up of 4 units together with 10 units. So I have 6 times 4 plus 10. Why am I adding the 4 and the 10 together? To get that whole side right there. You guys okay with what I've got so far? This is example number 1, and we're going to look back on this as we move forward with some other examples. 4 plus 10 gives me 14. 6 times 14 is how I got the area of the whole thing to begin with. Or I can distribute, and I get 24 plus 60. And then I add those together, and I get the area of the whole thing, 84. These are all equivalent ways of expressing the area. They look different, but they all have the same meaning. I get the same outcome, the same total area. So far, so good? Okay. So here's what I want you guys to do. Somewhere else on this page, or if you do a really huge rectangle and you need to, there's more dot pages. You can move to a different page if you need to. we're going to draw a more different rectangle. The first part of the instructions stay the same. I'm going to start on a dot and end on a dot for my vertical part. So pick a dot to start at, start on a dot, end on a dot. Doesn't matter how big or small you make it. Across the top, though, I'm going to start on a dot, and I'm going to end in between two dots. So I'm not going to extend it all the way to another dot. So I'm going to come across the top, and I'm going to stop it somewhere that's in between two dots. Something like that. Count the vertical side. See how tall it is. Again, we're counting spaces, not dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I've got one that's 10 here. So far, so good. I can't count across the top this time because it's not a whole number of units. I could estimate it and get close, but I don't know exactly how big it is, right? So I can't put a number for the whole thing across the top. Pick a spot, once again, on the inside of the rectangle where you're going to cut it. Pick a spot where you're going to draw on top of those dots. This part I can figure out how big it is, right? Starts on a dot, ends on a dot. I can count the spaces in between. 1, 2, 3, 4, 5. Mine is 6 right here. Can I be precise about this other part? No, because it doesn't end on a dot. Since I can't be precise, I can't put a number there. What could I represent it with if I don't know exactly how big it is? X. I can put a variable here. So how big would this whole side be if I put those two pieces together? 6 plus x. Because I know the one section is 6. I don't know how big the other section is. You guys following so far? Okay. I want to express the area of this as both a sum and a product. So we're going to write the sum form, and then we're going to write the product form. For the sum form, I need the area of each of these rectangles. I need the area of this one, and I need the area of this one. How do I find the area again? Length times width. So for the one that on my picture I scribbled in with blue, what am I going to multiply together to find that area? 10 times 6. So on mine, this one has an area of 60. So I would have 60 plus, for the purple one, I'm going to take 10 and multiply it by what? X. 10 times x, so that would be 10x. I can't simplify it any more than that. I have 10x on the one side. Because I know my length, the height on that, is 10 units. But I don't know how wide it is because I didn't stop on a dot. So I've got the area of the first one was 60. The area of this one I did 10 for this side times x for this, and I got 10x. So to find the area of the whole big rectangle, I add those two together. So I have 60 plus 10x. We doing okay? You look confused, Azina.
The 10 was the top part?
No, the 10 is over here. Right here.
Oh,
That's this side right here.
sorry.
No, that's okay. I'm glad it was an easy question to answer. Product form. I want to multiply the length times the width on this whole rectangle. How big is my length here? 10. So I have 10 times, how did I express the whole length across here? 6 plus x. So here's my product form, and here's my sum form. What property could I use to get from product form to sum form? I could use distribution. 10 times 6 would get me 60. 10 times x would get me 10x. Product form often gets called factored form. Do you guys remember learning how to use an area model or a box in Algebra 1, Algebra 2 to factor things? This is what it's based on. This is why in my class I call it an area model, because it's based on length times width for a rectangle. That's my example number 2 here. Yeah, we're just writing it in sum form and product form. Because right now we're not solving anything, we're writing things that are equivalent. Look different, have the same meaning. Yep. So far so good? Okay. We're going to draw yet another more different rectangle. So for this one, when you do the vertical part of your rectangle, start on a dot but end somewhere that it's not on a dot. Same thing across the top. So you're going to start on a dot, end in between 2 dots for the length and the width. Start somewhere on a dot, but end before you get to another dot. Start on a dot, end before you get to another dot.
For both sides.
Yep. Same shape, still a rectangle, except for the vertical part, you're not going dot to dot. You're going dot to somewhere in between 2 dots. Am I able to precisely count how tall this is? If I don't know exactly how big it is, what could I do? Yep. I can give it a variable name. I can call it x. I'm going to cut my rectangle again because I want to be able to count some of this. If I draw it right on top of dots, can I count exactly how big it is? From the left edge to where I drew my line? Yes. As long as I drew it right on top of dots, I can count how many squares big it is. So count the space in between. 1, 2, minus 3. For the other part of my rectangle, can I be precise about how big this side is? Why not? It's in between 2. I could approximate it, but I'm not good enough to say whether that's 1/2 or 1/4 or 1/3. I'm not even going to try. Since I don't know precisely how big it is, what could I use to represent it?
X.
I already used x, though. Is it the same size as this one? I could use a different variable. Unless I know they're exactly the same size. If they're exactly the same size, then I could use the same variable. But if they're not, then I got to pick some other representation for it. So how would you represent the area of this side of my rectangle over here? Just that little piece. 3x. I would do 3 times x, and so I would have an area of 3x here. What about over here? Close. X times y, because remember we do length times width, so I would do x times y. So xy. How would I write the area then using sum form? I want to express the area of the whole rectangle altogether.
Would it be 3x squared?
Close. It's going to be, because when I take these two parts and I put them together, what operation do we use when we're putting things together? Addition. So it's going to be 3x plus xy. Yep. 3x plus xy. If I was multiplying those two, then yes, I would get that squared. And then I want to do product, sometimes called factored form.
So when we're writing the 3x times x, does the top, for the first box, does the top go first and then the side?
For this one?
Yeah.
So I'm just multiplying these two together. When you multiply two pieces together, it doesn't matter what order you put them in. So technically it doesn't matter whether I have the x first or the 3 first. It's just normally considered convention in math that if a number is involved with a variable, you put the number at the front.
Right, but does the second box doesn't matter?
No, you could have xy or you could have yx. Same exact meaning. Yep, good question. All right, I'm going to write product form, factored form next, and then we're going to finish up. That's pretty much going to be the end for today. How do I find the area of the whole rectangle altogether?
Add them together.
Add them together. That's my sum form. What about if I wanted to write it just as a single multiplication problem?
I want to do it. So you're going to say it's going to be a with parentheses of 3 plus
Yes. Why does it have an x outside the parentheses? Yes. This side right here is being multiplied to this whole side. Why is 3 plus y inside parentheses? Yes, the other side is made up of 3 together with y. And so I've got my sum form and my product form. When we use the distributive property, when we factor things, we are writing things that are equivalent expressions. Multiplying those pieces together, writing them in product form or in sum form doesn't change the value. It just changes the way it looks. All right, guys, please put the markers and colored pencils away. There is one last homework assignment in this unit. And we will pick up tomorrow.